So we can start now. So curve fitting. So there are two general approaches for curve fitting. The first one is the least squares regression, or this one is the curve fit, and the other one is the interpolation or force fit. In number one, the first one, which is the least squares regression, we're going to formulate an equation that will only follow the trend of the given data points. Not necessary that in those given data points, the curve that is generated by the equation will pass through all the given data points. So necessary lang dito is it will follow the trend of the given data points. But in the second one, in the interpolation, it is the force fit, we will formulate an equation such that the curve generated by that equation will pass through all the given data points. So that is the difference between these two approaches for curve fitting. So we go with the first one, the least squares regression. So this one is to derive an approximating function that fits the shape or general trend of the data without necessary matching or passing through the individual points. So example, in figure A, so meron tayong mga given data points here. So the data exhibiting significant error. So makita natin na kalat-kalat yung mga points natin. Then if you're going to use the polynomial fit, that will generate a curve that will pass through all the given data points, you will see here that the curve now will go beyond the range of the data. So that is what will happen. But if you use now the least squares regression, then we're going to consider now a straight line to represent now this given data points, because if you're going to see the given data points will give, or it will follow a straight line. So this straight line here, not necessary that it will pass through the given data points. So ang gagawin lang natin dito is we're going to minimize the difference between the line and the given data points. So yun ang gagawin dito sa least squares regression. So una dito is we consider the linear regression. So meaning we're going to represent those given data points. So assuming that those given data points are representing an straight line. So we use the linear regression. So the simplest example of least squares approximation is fitting line to a set of paired observations or points. So we have x1, y1, x2, y2, x3, y3, up to the last point or data point, which is x of n, y sub n. The mathematical expression for the straight line is equal to y is equal to a sub o plus a1x plus r. So our a sub o and a sub 1 are usually the coefficients representing the intercept and the slope. So from your algebra, you know that the equation for a straight line is y is equal to AO plus A1x, where AO and A1 are the x-intercept and the slope, while the R here will represent now the error or residual. So that is the value or the, yes, value between the model and the observations. Ipakita lang natin. Say, if we have now the straight line here, this is now the generated line using now the least square regression. And meron tayong given data points here. So we have yung red, that is the value of xi, y sub I. And ito yung na-generate natin na line using the equation, which is y is equal to AO plus A1 x. So we have that. So the difference between the model and the uh, given point should be the residual or error. So with the formula, y sub I, that is the value of y, then minus AO minus A1 xi, which is the value of the um, model. So the difference now is called as the error or residual. So this value, so that is the error. So that our equation now should be equal to this. Y is equal to AO plus A1x plus the error or the residual. And, okay. So that if we solve now the residual or the error should be equal now to y minus AO minus A1x. So naka-state naman dito na yung R natin or E is the discrepancy between the true value of y and the approximate value AO plus A1x predicted by the linear equation. So yung pinakita natin kanina. So that is our error. Then the criteria for a best fit is to minimize the sum of the squares of the residuals between the measurement y and the y calculated with the linear model. So, i-minimize natin yung sum of the squares, yung R natin dito. So, marami tayong mga points dito. Kailangan, it should be the minimum of the sum of the squares of the residual. Bakit square? Why not we simply add the residual and we consider the minimum? So that should not be a good measurement because yung R natin, yung simple R natin, pwedeng yung value niya is positive, pwedeng yung negative kung nasa baba yung points natin, and so on. And there's a tendency that if you add them arithmetically without squaring, what will happen is there's a tendency that the value is equal to 0. So meaning kung 0, without knowing the appearance of the this discussion, so kung 0 yung R mo, the summation, meaning the lines should be passing through all the given data points. So that is not a good measurement for a best fit. Ang nakita nilang pinakamaganda is we take the sum of the squares of the residuals, which is the smallest value. So, i-minimize natin yan. And from there, we can generate now the line to represent now those given data points by a straight line. So, yun ang ginawa dito. So, is to minimize the sum of the squares of the residuals or error between the measured y and the y calculated with the linear model. And we let those sum of the squares to be SR. So gamitin natin yung variable na SR dito to represent now the sum of the squares of the residual. And the formula to determine this should be equal to the summation of R sub I. So usually ang R natin dito is R sub I dito sa figure. So summation of R sub I is squared. Then I should be start from 1 up to the n. So n is the number of data points, or equal to the summation of y sub I measured minus y sub I model, then quantity squared, where our I starts from 1 up to n. So yung y sub I measured is usually the given data points yan. And yung y sub I model is the value of y in the derived straight line. So in equation now, our SR should be equal now to the summation of y sub I minus AO minus A1 x1, then quantity squared. Sorry, it should be xi to. We have xi, then quantity squared. So that is now the equation for the sum of the squares of the residual. Then for the least squares fit of a straight line, to determine the values of a sub o and a sub 1, which are the coefficient in the equation 1, is differentiated with respect to its coefficient and setting these derivatives to 0, that will result in a minimum value of SR. So based from our discussion, your subject in the differential calculus, so if you take the derivative of a certain function and you set that to 0, then the value that is determined there is maybe the maximum or minimum. So ganun ang gawin natin dito. So we will take the partial derivative of equation 1, that is SR, with respect to the coefficients, which are AO and A1, and we set that to 0. So if we do that, we have now this resulting equation. So first one here is the partial derivative of SR. So we know now the symbol for partial derivative should be looks like this. SR with respect to AO, and this should be set to 0 for minimum. So if we differentiate now that one, so based from the formula for calculus, differential calculus, so we use the power formula. So yung 2, so meron tayong 2, then multiplied by the summation of the value in the bracket, which is y sub I minus AO minus A1 xi. Then the power now will be minus 1. So 2 minus 1 is simply 1. Then multiplied by the derivative inside the bracket. So ganun yung formula. Since we are differentiating this equation SR with respect to AO, then yung y sub I should be considered as 0 in terms of its derivative. Yung AO is with the derivative equal to negative 1. Okay? So yun ang pinaka-variable natin, AO. So meron tayong negative 1. Then the derivative of A1 xi is also 0 because that is constant. Kaya ang lumabas dito is meron tayong negative 2 multiplied by the summation of y sub I minus AO, A1 xi, where our I starts from 1 up to n. Kaya we come out with this result in taking the partial derivative of SR with respect to the coefficient AO. So, yan. Ganun din ang gawin natin. If we're going to take again the partial derivative of the same equation with respect to the next coefficient, which is A1. And we come out as the result now as negative 2 multiplied by the summation of y sub I minus AO minus A1 xi, then multiplied by xi, where our I starts from 1 up to n, and it should be set to 0. So, ganun ang na-derive natin na equation after taking the derivative of equation 1 with respect to AO and with respect to A1. Then we're going to simplify now this resulting derivatives. So, in the first equation na kuha natin, so we can write now as, ito kung i-cross multiply natin yan, so 0 divided by negative 2 is it will become 0. So maalis yung negative 2. So remaining now is already the summation of y sub I. I-distribute lang natin yung summation. All the I should be counted from 1 to n. So yan. Then minus summation of AO. Then minus summation of A1 xi. It should be set to 0. Then for the second equation, so ganun din ang gawin natin. So cross multiply. So maging 0 divided by negative 2 is 0. So maalis na yung negative 2 doon. Then distribute the summation inside and also distribute xi nasa labas ng bracket. So that we have now summation of y sub I times xi minus summation of AO times xi minus summation of A1 xi squared equal to 0. So, yan. Then further simplifying and rearranging the equation, we arrive now with this value. So, i-move natin yung summation of AO to the other side of the equation. It will become positive. And this value, if you're going to see that, so yung AO naman is wala siyang I. So meaning, yung AO should be AO plus AO. Ipakita ko lang dito para hindi tayo malito. Gagamit ako ng ibang kulay. So this value, the summation of AO, where I starts from 1 up to n is the same as AO plus AO plus AO up to n value. And so if you're going to write this one, is simply equal to AO multiplied by the number of data points. So we come out with this as the value now for that summation. Then ganun din sa summation of A1 xi, if you move that to the other side of the equation, it will become positive. And pwede nating ilabas yung A1 and the summation. So that the remaining and the summation is simply the summation of xi, where our I starts from 1 up to n. And yung summation of y sub I should be remain as this one. So we arrive now to this equation from there, okay? So, and then the next one, so ganun din ang gawin natin. We simplify further the equation and rearrange. Then we arrive now with this equation. So it should be AO multiplied by xi. So yung I natin is always from 1 to n plus A1 times the summation of xi squared should be equal to the summation of the product of y sub I and xi. So ito yung dalawang equations natin na gagamitin natin to solve the values of AO and A1. Because yung mga values ng x and y natin are given, and also n is the number of data points. Therefore, the only unknown in these two equations are the coefficients AO, A1. And these values of AO that is determined in that equation will give to us the minimum or less value of the sum of the squares of the residual. So, isutik ka acid gun nga line nga ma-generate natin with these values of AO and A1 with respect to the given data points. Kasi kung we go back with our illustration, so kung meron tayo mga data points na ganito, so there are several values of AO and A1. So pwedeng ang makuha natin na AO and A1 will give to us this line. Another value is maybe we consider this line. Or we have also a line like this to give us a certain value of AO and A1. So yung value ng AO and A1 na makuha natin with this given equation, yun ang pinaka malapit dito sa mga data points. Meaning, we have the least summation of the squares of the residual. So that is the meaning for this. By the way, later on, using statistics, we can determine how this curve or this line fit to the given data points. So in terms of percent, we can determine how fit is this one. So let's try to consider now an example to illustrate now this discussion. So we're going to remember only this equation, yung dalawang last. So AON plus A1 times summation of xi should be equal to the summation of y sub I for the first equation and yung second equation. So the numerical example here is we are required to fit a straight line to the given values of x and y. So the values of x are the following. We have 1, 2, 3, 4, 5, 6, 7. And the corresponding values of the y for these values of x are also the following. We have 0.5, 2.5, 2, 4, 3.5, 6, and 5.5. So we're going to fit now this given data points by an straight line. So ano yung mga kailangan natin na values based from the equation that we derive here? We need the summation of xi. So meaning we add 1, 2, 3, 4, 5, 6, 7. We need also the summation of y sub I. So we need to add also the values of y, 0.5, 2.5, and to the last. We need also to determine the summation of the values of x squared and also the summation of the product of y and x. Para mas madali yung calculation natin, we're going to consider a table na lang similar to this one so that we can compute all of those values. So for the first column, we consider the values of x. Second column is the values of y. Third column is the square of the values of x. And the last column is the product of x and y. So we copy the values of x. So we have 1, 2, 3, 4, 5, 6, 7. And if we add all of this, we come out a value of 28. So 28 yan. And if you add also all the values of y sub I, we have 24.
But would
Ay,
pasalo ng Pasqua.
group 1. Sungawan ba?
Pagkanan lang namin Jay Cashier sir. Ay ko alat Jay Jay Malaga.
Okay. Okay, so we continue.
NSTP.
What? Okay, so we squared the values of x. So 1 squared is 1. 2 squared is 4. 3 squared is 9. Up to the last, it is 7 squared is 49. And we add all of this squared values of x to come out with a value equal to 140. Then yung product, so this 0.5 is the product of 1 and 0.5. from the values of x and y. 2 times 2.5 is 5. 3 times 2 is 6. Up to the last na 7 times 5.5, that is 38.5. And add all of these values, we arrive a value of 119.5. So ito yung mga summations na nakuha natin. And if we go back with the formula that we derived and substitute these values, we have now this one. So ipakita ko lang yung formula na AON plus the summation of, so usually A1 summation of xi equal to summation of y sub I. Ito yung unang equation natin. So ilan ba yung value ng n natin? So kung bilangin natin, there are 7. 1, 2, 3, 4, 5, 6, 7. That is the value of n. So that we have now 7 AO. Then yung value ng summation ng xi natin is 28. So kaya meron tayong 28 A1. And summation of y sub I is 24. So we have now this first equation that the unknowns are AO and A1. Yung susunod na equation is AO times the summation of xi. Hindi ko na ipakita yung counter. Plus A1 times the summation of xi squared should be equal to the summation of xi y sub I. The summation of xi is 28. So we have now 28 times AO. Then summation of xi squared is 140. So 140 A1 equal to summation of xi y sub I, which is equal to 119.5. So again, we have two unknowns here, AO and A1. And solving simultaneously these two equations to determine now the values of AO and A1. So you don't know how to solve this unknowns. So you can use any method. You can use by elimination, by substitution, using methods that you discuss in advanced engineering mathematics. And you can solve the values of AO, A1. Or you can use directly your calculator to solve the unknown. Two equations to unknowns. And if you solve that, the resulting value now of AO is 0.07143 and A1 is equal to 0.83929. Then, based from the equation of straight line, that is y equal to AO plus A1x, then we have now the resulting equation of the straight line. It is now 0.07143 plus 0.83929x. So that is now the equation that is fitted now, the most fitted to the given data points. So kung i-illustrate natin to para ma-visualize natin yung ginawa natin na solution for this, i-plot lang natin, okay? So we consider the x-axis, bale 7 yung value, 1, 2, 3, 4, 5, 6, 7. Ito yung x-axis natin. So numbered as this. Then yung y natin, ang pinakamataas na value doon based from the given is 6. So we're going to calibrate also the y-axis up to 6. So we have 1, 2, 3, 4, 5, 6. So this is the origin. And 1, 2, 3, 4, 5, 6. So itry lang natin na i-plot yung mga given na data points para ma-visualize natin mamaya. So una is meron tayong 1 and 0.5. So kung tingnan natin yung point for that, so ito yung 0.5, ito yung 1, so ito yung unang point natin. Then yung susunod is x equal to 2 and our y is 2.5. Therefore, our next point is ito, yung mga red. Then 3, 2. So ito lang yung 2 natin. So we have this another point here. Then 4, 4. So parehas lang. So the point generated by that should be ito. Then 5, 3.5. This is assuming ito yung 3.5. Then 6, 6. This is the point. Then 7, 5.5. So these are the given data points. Then i-plot natin yung na-determine natin na equation. So that is a straight line. So maybe we consider only 2 points. So maybe we consider at x equal to 1. So if the value of x is equal to 1, then we simply add AO and A1. So we have 0.07143. That is AO plus 0.83929 to arrive a value of 0.91. So 0.91 ang nakuha natin. So almost 1. So nasa taas ng data points. So yung green ang gagamitin ka. Then when x equal to 5. Okay? So dalawang points na lang ang kunin natin, then i-connect na lang natin na straight line. So if the value of x is 5, so 5 times 0.83929, that is the value of A1, then plus 0.07143, we have 4.27. So if the value of x is 5, the value of y is 4.3. Sabihin na lang natin na 4.3. So about somewhere here, less than 4.5. So nandito yung point natin. Then i-connect natin ito ng straight line. Or pwede rin na i-generate natin lahat yung mga values. So this is now the line that gives to us for that given equation y is equal to 0.07143 plus 0.83929x. So that is the derive. And this equation or line is the best fit for this given data points. Siya ang pinakamaliit if you add all the residual squares. So ito ang pinakamaliit. Kasi kung tingnan natin dito, so ipakita ko lang yung mga residuals natin. So meron tayong residual dito. Okay, gawin natin na R1. Then meron naman tayong another residual dito. R2. Then next is again here, another residual. R3. Another residual here. The difference between the given data points and the model with R4. Then another here is R5. Then another R6. Then the last here is ito, R7. Na kung i-square natin lahat yung mga R1 plus R2 squared plus R3 squared and so on up to the last, yun ang pinakamaliit na value. Comparing, if you consider other values of AO and A1, the value now of the sum of the squares or SR is greater than that value. So that is the meaning na ito ang pinaka-best fit in discussion, so that if you consider other values na of the coefficient AO and A1, you have a larger difference now between the model and the given data points. So question with this, mga surutan niyo. So how could we arrive with the equation of a straight line to represent now those given data points? So titandaanan tayo lang is yung na-derive natin na equations na dalawa dito. This one. Then if you know this equation, then we can formulate now an straight line to represent now those given data points. So question? Surutan nyo. Ang sarag dingding.
Dolar.
Surutan nyo. So, number, masapol nga mo yati because if we go on, later on, we go with non-linear. So, we still use the same principle as this one. So, let's say to continue, we will discuss how could we measure now, how fit now this equation or line na determine natin to the given data point. So, using statistic, so the quantification of error for of linear regression. So the formula is we have R squared is equal to ST minus SR divided by ST, where our R squared is the coefficient of determination. So from your statistic, the subject. And if you take the square root of that, usually we come out with the value of R, and that is called as the correlation coefficient. Okay, so your ST should be equal to the summation of y sub I minus y bar, that is the mean. Y bar is the mean square, or this one is the total sum of the squares of the residuals between the data points and the mean. That if the resulting value of R squared, which is also equal to R, is equal to 1, meaning it is a perfect fit, signifying that the line explains 100% of the variability of the data. Fit na fit, meaning yung na-derive natin na equation, and if you're going to draw the line for that, it will pass through all the given data points if the value of R is equal to 1. So perfect fit. But if the computed value of R squared, it is also equal to R, and it is equal to 0, so meaning the equation or the line that is generated is not no relation with the given data point, so no fit. The fit represents no improvement. Sila kung in our drawing kanina, if we consider a no fit is maybe ang na-derive natin na equation is maybe pa ganyan. Ito yung equation natin ng straight line. So there's no relation with that line to the given data points. So yung values natin for R squared for R should be with the range from 0 to 1. Okay? So kung 0.5 lang yung compute natin, it is only 50% na fit to the given data points. We have also another alternative formula for the computation of R. that is more convenient for computer implementation. So R is equal to this. So N multiplied by the summation of xi y sub I minus the summation of xi multiplied by the summation of y sub I divided by the square root of n multiplied by the summation of xi squared minus the summation of xi then squared multiplied by the square root of n multiplied by the summation of y sub I squared minus the summation of y sub I then squared. So that is another alternative formula. So let's say to compute now the correlation coefficient now with the problem that we discussed. So first here is we're going to compute the mean for the value of y. So the mean should be equal to the total value of y divided by the number of data points. So in our discussion kanina, meron tayong 24 na total for y sub I and divided by the number of data points na 7 to come out with 3.428571 as the mean. That is our y bar. Wait lang. Okay, so that is the mean. Then using now the formula to determine the value of ST, that is the sum of the square also of the residuals between the given data points to the mean, should be computed now as this one. So meron tayong column dito for ST. So ang unang nakuha natin dito is 8.576528. So how could we solve this? It should be y sub I, ito, 0.5. Then yung y bar natin is 3.42857. Then square that. Ang lalabas is 8.576528. So if you try to compute that, okay? So 0.5, so try to compute 0.5 minus the mean, that is equal to 3.428571. Then square that. The resulting value is 8.5 something. Then yung 0.86, ganun din, should be 2.5 minus 3.4 something, then squared, and so on. And after computing all these values, mga values natin dito, we will add all of this to arrive now to 22.71429. So ito na yung ST natin in the formula. Then for the sum of the squares of the residual, ito naman yung formula. It should be y sub I minus AO minus A1 X. So this 0.168690918 is computed as 0.5. Okay, ipakita ko lang dito. So this value is computed as 0.5. That is our y sub I. Then minus. So tingnan natin yung y sub, yung a sub O natin. So balik tayo dito sa natin kanina, 0.07143. So, this is 0.07143 minus yung A1 natin is 83929. So 83929. So isulat natin dito 0.83929 multiplied by x. So our x at that point is 1. Then gawin natin dito is i-square natin. So i-square natin. Ang lalabas na value should be that 0.1686. So kailangan naka-square yan. And ganoon din ang susunod. Yung y natin, susunod is 2.5 and our x should be 4. So yan lang ang mag-change to arrive a value of 0.56 to something up to the last na given data points. And if you add now all of these values, we have now a value of 2.9910 something as the value of SR. So this is our SR. And in the formula of R squared na ST minus SR all over ST, then we arrive a value of 0.86832 as the value of R squared. And solving for R, it should be square root of that, that is 0.93183. So makita natin na almost already 1. So meaning that the resulting equation that we derive is 0.9 in terms of feet. So meaning these results indicate that 86.832% of the original uncertainty has been explained by the linear model. So pwede natin gamitin ito to determine how fit now the result now of our calculation. And you can also use the other formula for direct computation. This one, yung R is equal to this, because in this case, we already solved almost these values. So meron naman tayong data for the summation of the product of xi, y sub I, and our solution kanina. We have also the value for summation of xi. Meron din tayong value ng summation of y sub I. So, ganun din dito sa mga iba. Okay? So, summation of xi squared, meron din tayo. Then, summation of xi, gawin lang natin is square lang natin yon. Then, summation of y sub I squared, ito lang ang wala. Then, meron tayong summation of y sub I, square lang natin yon to that value. So, and the result of this is still the same as the result here na 0.93184. So, that is now how could we quantify how fit now those derived equation using now this linear regression under the least squares regression. Disconnect ka na. Okay, so we will end now up to this point. Number 1 lang dito is the formula to be used to determine the coefficients AO and A1. So madali lang naman na i-familiarize. And if you want to quantify how fit now the result there, so we can compute now the value of R. So that's end of our discussion for this meeting. And we'll continue this next meeting.